Okay, all right. So here we are going to talk about the graphs of trigonometric functions. I will only write down graphs because we are already talking about trigonometry here. Okay, so in AS, we have three trigonometric functions, sine, cos, tan. And in A2, we will be talking about six trigonometric functions. So for now, let's talk about three trigonometric functions and about their graphs, okay? So the first one is the sine function. Y is equal to sine of X. So you guys already have some idea about it because, one second. Because if you remember, we have already discussed the graph of sine, right? Okay, so this is basically the x-axis where I would be writing down the thetas because this is the angle. This is y-axis. And the basic general shape of sine x is, okay, please keep your mics muted, where this part is basically 1. This part is basically -1. And then if I talk about different theta, so this is basically 90 degrees. This starting point is certainly 0. This one is 180 degrees. Then here we have 270. And then the last one is 360 degrees. Okay, this is how the general shape of sine x is. Okay, we will talk about some different variations in the function and then see how exactly the graph looks like, but for now this is enough. Now this is just the graph from 0 degrees to 360 degrees. I can make the same shape on the back side as well. I can make the graph over here as well, and I can just make this continuously until the end of y-axis, right? So the graph of sine x is basically the same, right? But this is the most important part that you need to understand. Okay, all right, everything would get better in some time. Just relax. Let's talk about the next trigonometric function. The next trigonometric function is basically y equals cos of x. Okay, so let me just make the graph of y equals cos of x. All right, okay. For the graph of y equals cos of x is something of this type. This point is again +1. This point is -1. This is my y-axis. This is my x-axis. And if I talk about the theta values, so this one is certainly 0. This is 90 degrees. Then at the center or at the middle, we have 180 degrees. This one is 270. And this is 360 degrees. Okay, now this graph would be used at multiple places. Either the examiner is directly going to ask you to make the graph of cos, sine, tan, not this one, with some variations. We'll talk about that in some time. Then you guys know that whenever we come across a trigonometric equation that is equal to 0, we are referring to these graphs. Like there was a past paper question where we got sine x equals 0. So in order to process that, I did not talk about quadrants. I referred to the graph, and from the graph, I was able to see that at 0 degrees, 180 degrees, and 360 degrees, sine is 0. Okay. Similarly, if I want to see at what thetas exactly cos x is 1, so I can say that it is 1 at this point, and at this point x is 0, and it is 1 at this point, and at this point x is 360. So at x equals 0 and x equals 360, cos of x is 1. Okay, this way or the other these graphs would be used a lot. Okay, this was just some basic information about both the graphs, and this is again from 0 degrees to 360 degrees. And same is the rule. You can certainly make this graph continuously. Same shape would be repeated again and again, again and again, again and again, but it only depends upon the interval you need to make the graph on. Okay. Acha, this was about sine and cos. Let's talk about tan, and then we'll talk about their modifications. Okay. This time around, we have y equals tan of x. Okay. This is my y-axis. This one is my x-axis. Okay. I'll explain everything in detail, do not worry. Then we have a dotted line. Everything would make sense once you guys use your calculators and just match all the values. Okay. Even for this part, I can just make this part. All right, okay. Now, what is happening over here? This is 0 degrees. Then this dotted line is being made at 90 degrees. Then this is 180 degrees. This dotted line is coming at 270 degrees. And this is 360 degrees, right? So again, this is basically from 0 degrees to 360 degrees. Okay, now how exactly and why exactly am I making the graph this way? For that, you guys need to take out your calculators and just cross check some values. Okay, just see what exactly you get on your calculators when you do tan of 90. Just check that. Tan of 90. I'll wait for 5 to 10 seconds. Just check. Very good, right? So you guys would be coming across an error because at tan 90 and at tan 270, the value is basically infinite, right? This line right here is going straight all the way up, and this is approximately going to be infinity. Now infinity is not defined. We are not sure when we say infinity, what exactly do we mean? So that is why we just make a dotted line at 90 degrees and a dotted line at 270 degrees. Okay, and the remaining should be fine, right? The remaining ones should be fine. Also, tan of 45 gives you 1. So at times it's a good thing to just mention that too. This, okay? So this is how exactly y equals tan of x looks like. And I can certainly, just the way I made the graph initially, I can also make the graph over here as well. That would be fine. Again, a dotted line would be made at 90 degrees and so on, but that is not needed for this part, right? You will certainly get to see this as well once we talk about the past paper questions. Okay, for now this is the basic shape from x equals 0 degrees and 360 degrees. It's the shape between 0 and 360. Okay. All right. Now, this was some basic stuff, some basic shapes, which I suppose you guys would be familiar with already. The important part is coming now. Now we need to talk about the transformations of trigonometric functions. So transformations is something that you guys already know. Like we have already discussed transformations, right? In the second chapter. But now we will talk about transformations of trigonometric functions. So this is very, very important. And this is the main thing. Okay. All right. Let's talk about transformations of trigonometric functions. And if anyone has any query during any, time of the lecture, feel free to ask me, okay? Acha. The first one is the graph of y equals a times sine of x, okay? So, first of all, every time we would be referring to the basic shape, and then I'll make the transformed function as well, just so we get to see the difference. Okay. If I talk about simple sine of x, so simple sine of x is something of this type. This point is basically 1, and this point is basically -1. Then at this part, we have 0. This is 90. This was 180. This is 270. And this is 360. This is y equals sine of x. What would be happening when I would make the graph of y equals a sine of x, okay? So for this, you need to think about some old knowledge that what used to happen when we used to multiply a number with the function. So it used to be a stretch along the y direction. You can say y direction, you can say y-axis, both are fine. And the stretch factor used to be a. If you guys remember, if you guys just try recalling this concept, we have already discussed transformations of functions, right? So whenever a number was being multiplied with the function, the graph was basically stretching along the y-axis and the scale factor was basically a, right? Whatever number we were multiplying. So for instance, if I say that this time around we want to talk about the graph of y equals 2 sine x, what would happen? My graph, my pink graph is going to stretch vertically by a stretch factor of 2. So these x-intercepts are not going to change. All the concept is exactly the same, whatever way we have discussed at that point as well. And this is what I would get, right? So this would become 2. This would become -2. But again, just like I've mentioned earlier as well, these x-intercepts are still the same, right? X-intercepts are not going to change because what is happening? Every y coordinate is being multiplied by 2. So if I talk about the y coordinate at this point, at this point, at this point, the y coordinate is 0. When I will multiply that 0 with 2, I would again get 0. So nothing is going to happen to the x-intercepts whenever the stretch is being made along y-axis, okay? And every other point would be multiplied by 2 and I'm going to just stretch my graph along the y-axis. Any confusions with this part?
No, miss.
So this is the
No,
graph.
miss.
Okay. This is the graph of y equals to sine of x. And this one is basically y equals sine of x. Okay. All right. Acha. This was basically when we were multiplying a number with sine of x. Okay. What would happen when I would have something of this type? It's sine of ax. Now, a is being multiplied with x. Okay. So for this, we need to refer to the basic idea. This is x, this is y. And again, first of all, I am going to talk about the basic shape. So do not focus on my lines and all of that part. I am mentioning everything. Again, this is 1. It looks like we have 2 lines here, so it would be 2. No, that's not the case. I'm just making a big graph for your understanding. This is -1. This is 90. This is 180. This is 270. And this is 360. Okay. Now, this is something that I would want you guys to comment on. What is happening over here? Or let's say, what used to happen when we had f of ax? So when a number was multiplied by x again, it was a stretch along x-axis or x direction, and the scale factor used to be 1 by a, right? So if I say that I want to talk about the graph of y equals sine of 2x, how is the graph going to be? It is y equals sine of 2x, right? Can anyone comment on this? Because we have already studied transformations.
Miss, the graph to be drawn is going to be x divided by 2. So every coordinate of the x is going to be divided by 2.
Very good. Yes, excellent. Okay. Every x coordinate would be divided by 2. This means, and this is something I've already explained, whenever we are multiplying a number by x, again, we are going to call it a stretch, but it is not going to be a genuine stretch. Our graph would basically become smaller, right? So just look at this now. Okay. So we are going to start at this point. This, because it was initially ending at 180, but I would do 180 divided by 2 and this would give me 90. Okay. And then the final shape is ending at 360. But since it is sine of 2x, so every x coordinate is divided by 2. So 360 divided by 2 gives you 180. So this is going to be something of this type, right? And again, you need to make the graph from 0 degrees to 360 degrees. So I am going to repeat the same shape like this. And this is going to be the graph. Okay, now please pay attention. Everything would be understood in some time. Do not worry. Okay. Acha. We are clear with whatever was happening when we multiplied a with sine of x. Things look like how they genuinely were, right? Now, some students think that when we have this for the graph, this should have been the case. Like something of this type, right? This is what some students say. This is what they think, that why didn't the blue graph just stretch along the x-axis genuinely? This did not happen because of the scale factor. My scale factor is not going to be 2. My scale factor is 1 by a, okay? And a is basically 2. So my scale factor was basically 1 by 2. Now with 1 by 2 as my scale factor, I can certainly see everything would basically be divided by 2, right? So this is what I would get for the original blue shape, right? But since I was supposed to make the graph between 0 and 360 degrees, so I've repeated the same shape until I reach 360 degrees. So this pink graph is basically the graph of y equals sine of 2x, and the blue graph is the basic graph, okay? Any confusions, Abdul Rahman, Munja, Rafe, and Motasum?
No, miss. Thank you.
About the 0, which is
Hmm.
greater than x and greater than 360, means this thing has to be the same in all graphs.
Yeah, this depends. This depends. The examiner would clearly mention that, right? It could be that he says just make the graph between 0 and 180 degrees. Just like the interval used to be different for different trigonometric equations. So again, the interval can be different, right? He can also say just make it between 0 and 180.
Okay.
Munja, anything that you would like to ask?
No, ma'am. Thank you.
Okay. Abdul Rahman, do you have any questions?
No, miss.
Okay. All right. Perfect. Okay. Acha, this was just about some transformation in the function directly, like we were multiplying, we have basically stretched. So we have already discussed stretched in the past as well. Now we know that we have several types of transformations, okay? Now this is for you guys. A quick question for you guys. I am going to make the write the thing here. What would be happening if I have y equals a plus sine of x, and let's say my a is 1. So y equals 1 plus sine of x. Okay, yes. Let me just make the basic shape. Okay, again, the basic shape of sine is something of this type, right? This point is 1. Whenever you have y equals sine of x, the number here is basically 1, right? If you don't have any number. So that is why the maximum and minimum points are -1 and 1. This point is 0. This is 90. This is 180. This is 270. And this is 360. This is x-axis and this is y-axis. Okay. Acha. What would be happening for y equals 1 plus sine of x? This is the idea, okay? Acha, what used to happen when we had something of this type, like a plus f of x? Think about this. Yes,
But it was like related to moving up and down.
Yes, very good, very good. Okay, so this basically had a special name, just like the previous transformation was stretch. This was basically translation, right? This is called translation. It's good that we are getting to revise all of that. It's translation. And for stretch, we used to write down the scale factor. For translation, we write down the translation vector. And the change is being made along y axis only, right? So this part used to be for x, this part used to be for y. And if I talk about our scenario, this would be 0 and a. And if I talk about this specific example, so the translation vector is going to be 0 and 1. So 0 and 1 means you have different points on the graph, okay? Just pick up a few points. pick this point, pick this point, take this point, take this point, and just add this translation vector. How would you add this translation vector? So let's say this point is 0, 0. Add 0 to x-axis, add 1 to y coordinate, okay? This is going to give you this point. Similarly, this point has coordinates 90 degrees and 1. So when I will add 0 and 1 to it, 90 would remain same and 1 would basically become 2, right? This way, or directly just move your graph 1 unit above. All right. So when I will move this graph 1 unit above, it is going to be something of this type, okay? Again, nothing has happened to the x coordinates. Everything is same. But just imagine that you have just picked the blue graph in your hands and you have just moved the blue graph 1 unit above. Just pick the graph and take it 1 unit above, and then you would get this yellow graph, right? So this is basically for y equals 1 plus sine of x. Okay, any confusions with this?
No, ma'am.
Okay, very good, well done. Okay, the next part, I am just going to write down the thing, and I would want you guys to just make it and send it to me on WhatsApp. It's fine if you're sending me wrong drafts, I don't mind that. I just want to see if I'm able to explain properly or not. Okay, and I would not mention if anyone was not able to make it properly, so that's fine. Okay, we are grown-ups now. Okay, the next graph is basically, the topic is y equals sine of x plus a, and you specifically need to make the graph of y equals sine of x plus 90. And I will just give you a quick reference to this just so you guys know some basic stuff about it. So if you remember, we have already discussed what used to happen when we had x plus a. Again, this is going to be a translation. In translation, things are moving up, down, or right, left. It's basically along the x-axis, so it would either move right or left. And your translation vector is basically minus a and 0, right? If you have positive a here, the translation vector used to be negative a and 0. So just look at it and then make both the graphs. So first you need to make the basic shape and then make the proper one. I'm just making the basic shape. This is x-axis, this is y-axis, and the basic shape is something of this type. It's 1, this is minus 1, 0, 90, 180, 270, and 360. So just make this basic shape and then make this one. I am going to wait for 2 to 3 minutes and then I'll see your attempts. Okay, just send me your attempts on WhatsApp basically. And if you have any question while drawing this, please ask me. Also, just make it between 0 and 360 degrees. Anyone who's done can just send me on WhatsApp. So are you guys able to process the question at least?
Miss absent.
Okay, okay. Oh, yes, yes, yes. I just got it. Yes, very good. Excellent. Well done. That's correct. That is correct. Very well done. Okay, perfect. So I'll explain this, okay, for the other students. Okay, it's completely fine. This is considered to be a bit difficult whenever something is happening along the x-axis, because every time it's other way around. Okay, now we have sine of x plus 90. One thing is certain, whenever we are adding or subtracting something in x or the entire function, it is going to be translation. And always remember, if you were, let's say, adding 90 to the function, you would have seen that as well, right? That would have made a lot of sense, because whatever you will do with the function, you would get to see that directly. Like when you multiply 2 with the function, the graph stretched. When we added 1, the graph genuinely moved 1 unit above. So this is how things are when we talk about the function. But whenever you are adding or subtracting something in x, whenever you are multiplying something with x or dividing something with x, it's the opposite. Now, when you have x plus 90, let's just talk about the concept. So whenever you had x plus a in the past, the translation vector used to be minus a and 0, right? Every point would move a units to the left. So we have 90 here. So every point would move 90 units to the left. Okay. If I talk about this point, this would basically come somewhere here at minus 90, but I'm not interested in this because my graph has to be between 0 and 360. Let's talk about this point. This point is basically at 90 degrees. This would move over here. This 180 would basically move to this point. Okay, let me just erase the other dots because this way it would become confusing. I'm just making the blue dots now. Okay. Yes. Acha. Then what would be happening? If I talk about this point, that was basically at 270. So I will move this 90 units behind and it would basically come over here. Okay. Acha. Then if I talk about this point right here, that is at 360 degrees. So this would be moved 90 units to the back, and this would basically come here. And I do not have any other point, so I am just going to connect this. Now, the question was to make the graph over here, right? To make the graph from 0 to 360 degrees. So for that, what you're going to do is you are just going to think about the graph of sine first. I've told you earlier as well, the graph of sine would go on like this continuously, okay? So this point was 90. This is going to be 360 plus 90. That is going to be 450. Now this is the next point. So when I will do 450 minus 90, I would basically come over here. So I just need to connect this point, and the blue graph is basically going to be my graph. Okay. Now please pay attention and explain this again. And then if you have any queries, you can ask me. Okay. Acha. Things were very easy. Life was good before this example because this is translation along the x-axis, and actually we were adding 90, but when we look at the graph, every point is being moved 90 units to the left. Okay. Another thing, I did not change the y coordinates. For example, please pay attention. At this point, the y coordinate was 1 and the x coordinate was 90. This was 90 and this was 1. My translation vector is going to be minus 90 and 0. So minus 90 would be added here. This would become 0. So here is the blue point. The x-axis is 0. And when I will add 0 to 1, this is just going to be 1. So the y coordinate is not going to change. If I talk about this point was basically with y equals 0 and x equals 180 degrees. I've moved it 90 units to the back. And what about the y point? Y coordinate is still 0. Okay. Let's talk about this point. At this point, x is 270 and y is minus 1. I've just moved this 90 units back and I got this point. Again, this point still has y coordinate as minus 1. Only x coordinate has changed. Okay. Let's talk about this one. What is happening here? My y coordinate is 0 and x coordinate is 360. So I've moved this 90 units to the back. So only x coordinate has changed. Y coordinate is still 0. And at 270 degrees, I was clueless because I did not have any point further. But as you guys know, we can make the graph of sine, cos, tan continuously. So I just made the graph quickly like this, and I know this would be the next graph, and I just took this point. It's 450 and 1. When I will move this 90 units to the back, this would become 360 and the y coordinate is not going to change. That is still going to remain 1. So that is how I got the blue graph. Okay. Yes. Now you can ask me if you have anything. Munja, Abdul Rahman and Motasam, and even Rafe as well.
Miss it, like
Hmm?
for this one, it's sine x plus a. So if it was x plus 1, something like that. So it would be like minus 1 to the left.
Yes, if it was x plus 1, that would have been minus 1 to the left. Yes, very good. That's right.
Okay.
But usually for the x-axis, whenever the question would be about a trigonometric graph, the examiner would not give you one. Like he can give you 45 degrees, 90 degrees, 180, something of that type, but not 1, 2, 3. It has to be an angle, so it would be, an angle that is good enough or big enough, maybe.
Okay, miss.
Yes. And what about the other students? Were you able to understand all of it? Motasam, please tell me honestly. You can ask me as many questions. Munja, you can ask me as well. Abdul Rahman, you're new here. Please ask me.
Miss,
Yes.
Miss, in the fx, what happens if we like subtract it? In the vector, we change it to +9, for example.
Okay, wait 1 second. Let me write it again. You want the change in where? Okay, wait. Like over here? This one?
Yeah, miss, because like for example here, sin x plus 90, but I want to change it to negative 90.
Okay, very good.
Yeah.
Right. So this should be x minus 90 when this would be x minus 90. This would be a translation vector. Are you talking about this?
Yes, miss.
Okay, very good. That's a good question. Let's talk about this as well. That was a good question. Okay. Let me just fill in these blue dots. Okay. Now Modism is saying that instead of having x plus 90, what would happen if we have x minus 90? Again, things would be other way around. When we look at x minus 90, we usually expect that our pink graph or this current graph would move 90 units to the left. But this is not the truth. Our translation vector would basically be positive 90 and 0, and this graph would basically move 90 units to the right. So just imagine that you are going to pick this graph and just take it 90 units to the right. That is it. Okay. So this point right here, that is at 0 at this point, would basically move to this point, okay? Then the next point is over here. This point would basically be moved 90 units ahead. It would come over here. Then here is my next point. This would be moved 90 units ahead and it is going to be over here. And similarly, if I talk about this point right here, it's at 270. This would come over here, okay? And now let me just connect this. So this is going to be the idea. Now I can see that this is how the graph would be, but since this was our interval, okay, please be very careful with this. If the examiner wants you to make the graph or to keep the graph within this interval, do not exceed this interval, okay? And it is, oh yes, okay, this is what we have. Now obviously this is not from 0 to 360, this is from 90 to 360. So I can make some part of the graph here as well, okay? But for that, I would like to refer to this graph as well, okay? And I've told you time and again, I'm telling you, the sine graph is going to be something of this type. If I talk about this point right here, it's minus 90. This would basically move to this point, okay? And again, it is going to be at -1. So this is going to be the graph. Yes, this is going to be the graph motism, okay? So I've just exceeded the basic sine graph, like I made the part that I did not have initially, this pink part, this one, and just by referring to all the points, I've just moved all the x coordinates to the right side by 90 units, and I did not change my y coordinate. So this is why I got this blue graph, okay?
Okay, Miss.
Any confusions with this? And this exactly was basically the next question I wanted to talk about, right? Very good. Excellent. Okay. Abdul Rahman, do you have any question?
No, ma'am, not right now.
Okay. All right. Perfect. So 1 second. Let me stop the recording.